Okay, so now let's revisit the problem of spam versus non-spam. So what is that? So suppose you have the data, right? So you have the feature vector and you have the labels. Supposing, imagine that you could plot this particular, these features, right? So what I'm going to do is imagine that you could plot it in 2 dimensions, although it could be in, let's say, 10,000 dimensions if you are using a bag of words consisting of 10,000 words. So what we do is, supposing, imagine that you could plot it in 2 dimensions. So supposing, let's say I use plus for spam and minus for non-spam. So this is how it looks like. Let's say plus, all the points are somewhere here. Okay, so these are all points corresponding to spam. Okay, x1, x2, and so on. Okay? And similarly, you have non-spam. Let's say it's somewhere here. I'll write it as minus, right? So you have a lot of such data points. Okay, maybe once in a while you have a minus here and maybe you have a plus here. Okay, but that's okay. So what can you say from this data pattern? Obviously, the plus signs are on one side, minus signs are on the other side. That's the pattern, right? An obvious pattern that you can immediately recognize. Now, if you have to separate these 2 patterns, what is it that I have to do? Basically, just draw a line, right? Maybe a line like this, right? Which will separate the 2 patterns, right? Well, if it is not in 2 dimensions, let's say it's in 3 or higher dimensions, then the line wouldn't suffice, right? You have to put a plane that separates the 2 data sets. Do you agree? So now, what do you mean by learning or machine learning in this case? A very crude answer. So let me write that. What is ML here? A very crude answer is what? Can somebody guess? Can somebody guess? Okay, people who are here in the auditorium, can somebody guess? Okay, getting line equation, that's what somebody says. So that's correct, right? So if I know the line, I can say whether the point is to the right or left, right? So if it is to the left, I say it's a spam. If it is to the right, I say it's non-spam, right? It's as simple as that. So the answer would be finding the line or a plane, right? Finding the plane. So how do you find this plane? So before that, I need to know what is this equation of a plane, right? So what is the equation of a plane? Can somebody tell me what is the equation of a plane or a line? Line is mx plus c, right? So of course, everybody knows. What is the equation of a plane? It's something like A transpose, yeah, ax plus by plus cz equal to something, right? In general, I can write ABC as a vector and xyz as a vector. So I can write it as W transpose x, right? So W is like ABC, right? So the equation of the line would be W transpose x plus B, right? It's almost like mx plus c, right? So why this represents a plane is something that we will look at when we study linear algebra. So this is the equation of a plane, okay? So now, what do you mean by learning? Learning means I need to know what is this W and what is this offset B, right? So if I know these, know the plane, and therefore I can figure out whether an incoming email is a spam or non-spam. Okay, so now how do you find that? Again, you have to pose an optimization problem that will end up giving us the spam or non-spam, the W and B, right? So how do you, supposing, let's say I give you W and B, that means I know the equation of a plane. So suppose there is an incoming email, I convert that into feature X. So you are supposed to tell me whether it's spam or not spam. Let's say you are to go and program or implement it on a hardware or whatever, right? So you have to write a program. Then what do you do? So essentially, what you do is you have W transpose. Of course, you have that. X is the incoming feature plus B, right? So this gives me a number. Do you agree? W transpose X plus B. Now I have to say whether this feature or the point corresponds to the point to the left of the hyperplane or to the right of the hyperplane, right? That's all I have to say. So how do you say that? Well, it's simply the sign, right? Sign of W transpose X plus B will tell me if it is positive, it's to the right, or negative it's to the left, and so on, right? So this is how I can decide whether the point is to the left or right, right? Do you agree with this, right? Okay, now supposing I have this data, right? So x1 you have y1, x2 y2, and so on. Let's say xn yn. You have n data points. So how do you figure out this plane, right, given these data points? So of course yi is basically +1 or -1, right? Spam or non-spam. So what do you do? So for example, what you do is you take this, right? So sine of w transpose xi plus b, right? So for the ith data point, this will tell me whether it's spam or non-spam, or supposed to tell me whether it's non-spam or spam. So the sign will tell me whether it's +1 or -1. Okay, so it's not really sign, it's slightly offset. Okay, so maybe I will say, so if it is sign, what does that mean? What will it give us? Sine function. What is sine of x? If you plot it, how does it look like? How does it look like? If it's positive, you will get what? Huh? You will get 1, and negative it's 0, right? It's something like an indicator. Or, okay, so let's define my own sign here. Okay, so sign is sine of x in my case would be +1 if x is greater than 0, -1 if x is less than or equal to 0. Is that okay? I'll define my own sign here. Okay, so now this sign here, sign of w transpose xi plus b, will give me whether, will tell me whether xi, the ith data point or the ith email, is spam or non-spam. So now I have to check whether it is true or not, right? So I have to check whether it is equal to yi or not equal. Whenever it's not equal, I have made a mistake, right? The hyperplane that I have considered is not a good hyperplane, right? So this is the error event, right? So whenever this happens, there is an error. So essentially what I have to do is to count the number of errors given these endpoints. So let me count this, I equal to 1 to n. So how do I count? Before that, how do I count this? Sine of w transpose xi plus b not equal to y. So this is an event, right? Whenever this happens, I should say 1. Otherwise, I should say 0, right? So that's called indicator. How many of you know what indicator function is? Indicator of x is 1 whenever x happens, right? So indicator of a is 1 whenever a happens, otherwise 0. Okay, is that fine? Whenever the sign is not equal to yi, it will be 1, otherwise it will be 0. So I'll count this, right? The total number. This will give me the total number of mistake that my plane would have done, right? So what I do now is I have to minimize this overall w, the vector w, and the bias or the offset term b, right? So if I could figure out what this b, w and b are, then I know what the hyperplane is, right? So this essentially gives us some w hat and some b hat, right? Right? So now what do I do in the future? So I just write a program wherein I take the input feature. How do you get the input feature? Easy, right? You take the mail, throw away a, b, c, a and b and all that. You have the bag of words, count the number of words that appear. You get the vector and take w1 hat, multiply by x1, w2 hat, multiply x2 and add them, plus add a bias b hat. Look at the sign. If it's positive, you say spam, otherwise you say non-spam, right? As simple as that. Now let's look at the implementation of this, right? So pictorially. So here we have the input. Okay, so we have, let's say the input is your feature, right? x1, x2, x m. Okay, so let's assume that you have m. This is your input feature. I'm going to feed it into this. So what do I do here? I take w1 hat, multiply the input x1 by w1 hat, multiply x2 by w2 hat, and so on, multiply this by wm hat. Okay, m hat or n hat. I think I've been using these two things interchangeably, but it does not matter. Okay, so is this clear? And add them. Okay, and I have to add a bias b hat, right? So now what do? I do sine, and this will tell me, well, +1 or -1, right? Have you seen this kind of an architecture before? Those of you who have studied or looked into, let's say, some part of machine learning, what is this? Okay, offline people. So, okay, yes, somebody told something. That's correct, right? Yeah. So it resembles perceptron, right? Right. Okay. Yeah. So I think Suman says it's neural net or perceptron. Yes, this is a simple implementation of a neural network, right? So you know the motivation, right? Why one should go for neural net. Okay. So let's go beyond this. So the problem is, you have to solve this problem, right? Minimize, indicate some of indicators of sine. Sine is also a very bad function, right? It has abrupt jumps and all that. Indicator is equally bad, right? Now, if you have some bad functions that I need to optimize over, it's optimize those functions, then it's really not a good idea, right? It becomes very hard in terms of finding out or optimizing this particular functions, right? So what do I do? So I have to make some, make some replacements that are nice, right? Proxies for the actual thing that I need. So what do you think is sine here? So let's plot sine. Okay, so what is sine? Well, sine here is this. It's +1 or -1, right? Well, there is an abrupt jump and it's constant. So if I want to replace this by a nice function, what do you do? Yeah, something like this, right? This is the first thing that people would have looked at, right? Do you agree? Well, if you use this in practice, what do I get? Suppose the x is here, you won't get +1 or -1, right? You will get some positive values. But remember, I can optimize, right? That's the good thing. So what do I do? So, typically in machine learning, you use so many, this is called an activation function, right? So you replace this with something nice, right? This something nice would be what is known as activation function, right? You have tan-hyperbolic and so many activation functions that people use. Okay, is this fine? Okay, so indicator I have to replace, right? What do I do with that? There are ways, right? So I can look at the difference mod, I can look at squared error, whatever, so many errors. But if you're looking at 1 - 1, there are other loss functions. For example, there is cross entropy loss and so on, right? Which we won't get into because that goes deep into the world of machine learning. But you should know that there is something called cross entropy and this other measures which can be used in this scenario, right? Which are nice. Okay. So now we have one neural network. So essentially, what is a neural network now for us? A neuron. It's a hyperplane, right? That's all. Now, suppose I have, it turns out that your data points when you plotted, it's not as nice as what you observed in the previous slide, right? So supposing, you have slightly more complicated. Okay, let me write that slightly more complicated. It looks like this. So plus is here, okay, all splams. Okay. And you also have, let's say, non-spam, right? So non-spam as before, let's say it's like this. Sorry, this is minus. And there are a few minuses here also. Now what do? Can you use a hyperplane to separate? Huh? What do you do? So the most obvious thing to do. How do you, suppose if you were looking at this, let's say, way back in the 1950s, just after Rosenblatt proposed the idea of neural network. So suppose you were to do the classification here, what is it that you do? Somebody answered curve, right? So yeah, so we can do, something like this, right? Very complicated curve, right? Well, I say if it is to the left of this curve, then it's spam, otherwise it's non-spam. Well, nice, right? So good. But what is this curve and how do you denote this curve and how do you optimize? And there are so many questions that one can ask, right? So always whenever you encounter some new problem, always try to convert that into your old problem, right? So somehow convert it into something that you already know how to solve, right? So what is it that you know how to solve? If it's separable by hyperplane, right? So now I can do this cool trick, right? So what is that? I'll put one hyperplane like this, right? Now, if I said if it is to the left of the hyperplane, it's spam, right of the hyperplane, it's non-spam. Whenever you get a point to the right of the hyperplane, you're always good in this case. Whenever it is to the left, you are in trouble, right? Why? It could be spam or non-spam. So what do? Put one more line like this. So now you say, it's like two neurons, right? Two perceptrons. You say first perceptron says it's to the left. The second perceptron says it's to the right. Then you say spam. Otherwise you say non-spam, right? It's really nice, right? So how does it look like this if you want to implement this? It's easy. Again, you have n points, x1, x2, xm. Okay. So the first one would be W11, W12, W1m, right? I'm going to add a bias. Let me call this as B1 and a sign, whatever. I'll call it a sigma, and this is the output, right? And now what do you have? I have another, right? So I have to write maybe one more like this, right? So what are these? This is W21, W22, and this is W2m. Okay, and you add a bias B2, and then you have a sigma. Well, you have the output. So what do I do with this? One more perceptron, right? So it should be to the right or left. So what do? What is one more perceptron here? Simple thing. Okay, so I'll ask you to fill. Okay, so what is this? This should be -1, right? One more perceptron is actually you don't need to do anything, right? You can just write an if-else statement in your code. You say the first perceptron says minus, that is to the left. The second perceptron says plus, that is to the right. Then you say spam. Else non-spam. That's all, right? So 2-3 lines of code. Okay. So now, of course, if you want to have very complicated, let's say there is a data set which is like this, okay? So suppose plus or like this. Minuses or like this. So what do you do now? Well, now you need a complicated curve, right? But can you approximate that curve? Yes, right? So you can always do this. You'll put one line here, one line here, one line here, one line here. So many perceptrons you put together to get any separation. So all that you have to do is make the layer deeper and deeper, right? This way. So then I can represent any curve and I can separate any data point. Okay. Well, there is a deeper theory to this. Well, you cannot always do this and get away with what, I mean, you cannot achieve good performance just by doing this. You have to do something more than this to achieve better performance, which is beyond the scope of this particular course. Okay. So any questions, those who are online, maybe I'll pause for 2 minutes. You can ask questions and then we will move on.